Guys, welcome back to the channel. Welcome back. This is MathStats. So, today we are talking about exponential and logarithmic equations. And today we're going to be doing some exercises. I'm not going to go on the I'm not going to even talk about the explanation because there is not much in this chapter. All they did was exercise. So there's not really any terms to know. But as I'm doing the video, I will be mentioning about some of the terms that we need to know. So, without any delay, let's get active. Let's say they tell you guys to solve for x, right? We need to solve for x. And on this point, I'm not going to be solving anything, meaning I'm not going to be giving you any number because it's to round to the nearest 10,000s. But I'm going to just do the steps and then you guys get to do the calculation at the end. Let's say we have something like this. 7 to the power of 4x minus 3 equals to 7 to the power of 2x plus 1. Remember, logarithmic function and exponential functions are the same thing, alright? They are the same thing, but written in a different way. So the same thing you would do for exponential is the same thing you're going to be doing for logarithmic. So in this case, guess what? They both have the same base, 7. So in this case, all we have to do is we can just equalize the exponent. So that would basically be 4x minus 3 equal to 2x plus 1. You see, because they got the same base, 7, then we don't need to worry about the base. As long as the exponent, we can find out as long as the base are equal, then we can actually work with the exponent solely. What would that be now? So that would be, I'm going to I'm going to add 3 on both sides, right? And subtract 2x on both sides. So I get 4x minus 2x, right? 4x minus 2x equal 1 plus 3. And we get what? We get 2x equal to 4 divided by 2 on both sides. Then we get x equal to 2. And that's your answer. Alright? So let's actually see if it is right. If we have 7 to the power of 4 times 2 minus 3, would that be equal to 7 to the power of 2 times 2 plus 1? So that would be what? That would be 7. 4 times 2 is 8 minus 3 equal to 7. 2 times 2 is 4 plus 1. And 7 to the power of 5 does in fact equal to 7 to the power of 5. So x equal to 2 is correct. Let's move on to another exercise. Now, what happens if you don't have the same the same base? What do? Okay, now we're gonna get to something that is a bit more complicated. So for instance, let's say we have 7x, 7 to the power of x equals to 10. What are we gonna do for that one? What can we do? Okay, in a case like this, what you're gonna wanna do, you want to take the common logarithm of each side of the equation. Okay, so what I'm gonna do is I'm going to take the log of both sides of equation. Yes, because when you have an exponential equation and you take its log, you bring it to its, I would say, more likely integral value or integer type. That's how when you take the log of an exponent, it's basically you are trying to divide a number by itself. Okay? So remember we had that if we have ln and e, then when you have an exponential function and you take its log, it's as if you are doing inverse multiplication or a division. So if I have 2 and I say I'm gonna say 2 divided by 2, then it's like saying I have an exponential function and I'm taking its logarithmic or its logarithm. So it's the same thing. So in this case, what I want to do is, because I want to get, actually, you know what, even a better way. You see over here, you see let me put a different color. You see right here, when we had this one right here, we divide by 2 to get x by itself, right? And then that way we can get x by itself. It is the same way. To get x by itself right here, because it's an exponent, we have to take the log of the log of the expression. So I'm gonna take the log of 7, log 7x equal to log 10. You have to take the log of both places. The same way when you did the division, you did the division for both places, then you have to take the log for both places. Now, what is next? We do have a formula. Log of a number with the power of something. If you guys remember what that is, do you guys recall what rule we can use right here for this one? Yes, it's called the power rule. The power rule. And what does it say? The power rule states you can take the exponent and move it in front of the log. So you can get x log 7 equal to log 10. Yes, right? Now, remember, we are looking for x. What does x equal to now? So now x is equal to, we're going to be dividing both sides by log 7, right? So that will be log 10 over log 7. And then you guys get to do the calculation. So whatever number you get approximately for x is that number right here. So in your calculator, do log 10 first, and then put log 10 in parentheses, divide by log 7 also in parentheses. Whatever number you get is the number for x. Let's do a second one because I'm pretty sure you guys might not understand that part pretty well. Let's do a second one. Let's say we have this 10x equal 37. Okay, and again, what I'm going to do is I'm going to take the log, right? I'm going to take the log on both sides. I'm going to take the log on both sides, right? So it's going to be log 10x equal to log 37. And I'm going to use the power rule, right? Use the power rule. And the power rule is what? I'm going to put the x in front of the log. So I get x log 10 equal to log 37. And then I'm going to use the quotient rule. Use quotient rule, right? So I'm going to divide by log 10 on both sides, right? So I get x equal to log 37 over log 10. Okay? And whatever you get here is the answer. Okay? That's how it works. Let's do one last one, and then we're gonna do a part 2 video because there's gonna be more for that. Actually, that's gonna be a very interesting one. What if we had something like this? 9 to the power of 3x equals 81 to the power of x minus 4. Remember, we are still looking for x. We are solving for x. Let me say this, guys. Don't, in mathematics, whenever you can find pattern, use the patterns as much as possible. Here, I could just use logs. I could just log. I could say, you know what, let's do log 9 3x equal to log 81 x minus 4. I could do that. But in that case, it is not a good thing to do. Actually, yes, it is not a good thing to do. What I'm going to do is, looking at the patterns, right? Look at the patterns. We have a 9 and 81. What do you see? Or is it true that both 9 and 81 have something in common? Yes, they both have 9 in common. So I can say 9 power of 3x equal to 9, right? 81 is what? Is 9 squared. So that will be 9 to the power of 2 times x minus 4. Okay? Yes. 81 is what? 81 is 9 squared. So in this case, what I'm going to do is, well, what that means, actually, let me write it a better way for you. Let me write it as the book would write it. 81 is basically 9 scoops, 9 squared, right? Come on. 9 squared, and then we'll have x minus 4. What does that mean? Now, remember the power rule or the product rule? Here we can do 9 3x equal to 9. I'm going to multiply 2 by x, that will be 2x minus 8. And now we have the same base again. So what I'm going to do, I'm going to just disregard the 9s. So I get 3x equal to 2x minus 8. And I get 3x minus 2x equal to negative 8. So I get x equal to negative 8. And guess what? That's your answer. So, guys, I'm going to stop it right here. We're going to do a part 2 video because there is more than just that. But for right now, I'm going to keep that one very simple and very easy because I don't want to get you guys, too bored with it. So, guys, don't forget, again, take a moment to hit the subscribe button and that notification bell so you can be alert when I post a new video. Of course, don't forget, you can hit my Cash App, PayPal, and Zelle. They are all down below in the description. If you like the video, give it a thumbs up because that will help with the algorithm so that more people can actually get to see the video. This is my stats. I hope to see you guys again. Until then, Masters out.